Hello and welcome back to this channel. In today's video, we are going to solve a problem on an object that is tossed vertically downwards from a height. And this is a kinematics problem. In this problem, the object is given an initial velocity. Now, let's look at the problem. An object is tossed vertically downwards from a height of 60 meters with an initial velocity of 10 meters per second. We are to calculate the time it takes to hit the ground, and we are to calculate the velocity with which it hits the ground. Again, because this is a kinematics problem, we are neglecting air resistance, and finally we are to take acceleration of free fall to be 9.8 meters per second squared. Now let's look at the solution. So with this problem, this object is given an initial velocity. So this object is not just dropped where the velocity would have been 0. In this case, the object is tossed with some initial velocity which is not 0. In this problem, we are given the velocity to be 10 meters per second. And that changes the complexity of the math in solving this problem, which I will show you step by step. So stick around. Let's look at the solution. Again, this is a vertical motion in one dimension. Therefore, we need to specify our coordinate system. So I'll choose the Cartesian coordinate system, that is the XY coordinate system. In this case, I have the vertical axis being the y-axis. Any vector that points upwards would be positive along the y-axis, and then any vector that points downwards would be negative along the y-axis. Again, we don't have any motion of this falling object along the horizontal axis because we are neglecting air resistance. So with that being said, we can draw a free body diagram to represent this problem. So we have the ball at this point, which I'll define as my 0 point, given some initial vertical velocity pointing downwards. So now our VI is 10 meters per second. Unlike in the case where it was just dropped without being tossed, the velocity is 0. In this case, the velocity is 10 meters per second, and the velocity vector, as we can see, is pointing downwards, so that makes it negative. However, this object is going to fall down until it hits the ground, and at the point where it hits the ground, it does so with some final velocity VF, which we are to find in the second part of this problem. Another thing we need to note is that acceleration of free fall G is given to us as 9.8 meters per second squared, and this acceleration of free fall is pointing downwards, and that makes it negative 9.8 meters per second squared. Remember, when we talk about vectors such as displacement, velocity, and acceleration, we need to specify both the magnitude and the direction. So the direction being the negative sign just tells us that the vector is pointing downwards, and any positive vector is going to point upwards per our coordinate system. Now, in this problem, we are to determine the time it took this object to start from its initial position. In this case, I'll place it here, y initial, until it gets to the final vertical position, that is hitting the ground, and that is given to us as the h. All right, so we are given h to be 60, so in this case h is going to be 60 meters. Now let's look at the kinematics equations again so we can have a good familiarity with them. All right, with this problem set up, first let's look at the data that we can take from this problem. We are given the initial speed, so 10 meters per second. We are given g, which is acceleration of free fall, to be 9.8 meters per second squared. We are given the height, the vertical height, to be 60 meters. And we are to determine the time it took this object to hit the ground. And also, we are to determine the final velocity with which this object hits the ground. So these kinematics equations are composed of 5 variables. And in this problem, we know 3 of them, and we are to find 2 of them. To find time to hit the ground, again, we make use of delta y is equal to 1/2 gt squared plus vit. All right, now delta y is simply y final, that is the final position of this object, minus the initial position of this object, minus 1/2 gt squared, and the velocity is also negative because initially it is pointing downwards, so minus vit. Now the y final, which is the final position of this object, is down here, which is if we take our initial position to be y initial here to be the 0 point, then our y final should be 60 meters, right? So the position at this point would be 60. So if we do y initial minus y final, so y final in this case below the 0 point would be negative h minus y initial, which is 0, and that will be equal to minus 1/2 gt squared minus vit. Now we can see that each of these terms have minus in it, so we can just take that away. 1/2 gt squared minus vit. So that simplifies to h equals 1/2 gt squared plus vit. All right, so now that we have this equation, we are going to substitute all our values and then determine the value of time. Okay, so we start with our h, in this case is 60, equals 1/2 g, which is 9.8, times the time squared plus the initial speed 10 times the time. So simplifying this further, we will have 60 equals 4.9 t squared plus 10t. We can take all the terms on one side so that it is equal to 0. In that case, we have 4.9 t squared plus 10t. So I'm choosing to take the 60 all over to the other side. So that becomes minus 60 and then equals 0. Now we have a quadratic equation. And with quadratic equations, we just need to use the quadratic formula, which says that x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. All right, and for a quadratic equation, it has the form ax squared plus bx plus c equals 0. Now our equation for the motion of this object is therefore 4.9 t squared plus 10t minus 60 equals 0. So if we compare these two equations term by term, we can see the a equals 4.9 in our equation, the b equals 10, and the c equals minus 60. So if we substitute that in terms of this solution, then the time is going to be equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. So you can pause the video at this point and then solve for the time. You should have time equals positive 4.7 seconds or negative 2.6 seconds. However, with this solution, we don't have a negative time. So the time we need to take is the positive time as our solution. So in this problem, it is going to take the object 4.7 seconds to hit the ground, which is completely different from the problem we solved when the object was just released from rest. And then with the negative time, which is the other solution, we don't have a negative time physically. So the physical interpretation is that the time has to be positive and it is 4.7 seconds. All right, with this problem, I'm going to stop right here and I'll let you solve for the second part of this problem, that is find the velocity with which this object hits the ground. You can refer to my previous video for when the object is just released or dropped from rest. All right, with this, the time it will take this object to hit the ground is t 4.7 seconds. I will be expecting to see your answers to the final velocity with which it hits the ground down in the comment section. Until then, I'll see you in my next video. Thank you.